Okay, we proceed to 1b. Okay, look at 1b. 1b here. A beam of white light passes through a diffraction grating with 10,000 lines per cm. A diffraction pattern is observed on the screen 2 meters away, as shown in figure 1. Okay, this one is the figure 1. So look at the figure. Okay, then let's look a bit. So you look at the figure, you can see ys. Okay, this one is yl. Okay, theta, theta. This one is s, and then l. Okay, theta l grating. Okay, diffraction grating x. Okay, from grating until screen. This one is my screen. Spectrum, spectrum. Right. Okay. Then we have n. We have d. Then look at the question. What is the question asking us to determine? Find the angle for the first order. Find the angle. Find the angle for the first order diffraction of the shortest. That's why you have the S here. That's why it's a YS. Okay. S stand for shortest. And then longest, this one L. Or you want to put as a L, capital letter. Okay, longest. Okay, longest wavelength, shortest wavelength. Okay, YL, YS, theta, theta, sorry, theta, then theta S, theta L. Right? Find the angle for the first order diffraction of the shortest and longest wavelength of visible light, which is 400 nanometer and 700 nanometer respectively. Okay, before we start our calculation or we solve the question, okay, let us list down all the information that is given. So I have n is given, right? So this one is given 1,000, 10,000, 10,000, 10,000 lines per cm, right? And then the D grating to screen. So you have D given is a 2 meter away. 2 meter away. 2 meter. 2 meter. Okay, what else? Lambda. Okay, shortest, longest. Okay, maybe I put it as a name. Shortest lambda S. Okay, 400 exponent 9 meter. Okay, then lambda L. I use the capital letter because I want to make it equal, same with the question given. Okay, it's 400, 400, shortest, longest, 700. So I put 700 here. 700 exponent 9 meter. Right, so we have to determine the theta. Okay, before we determine the theta, we have to determine the D. Okay, the D. Okay, so if I draw, okay, I draw here. Let's say this one is my grating. Okay, grating. So we have, okay, grating. Okay, here the lines, grating, here lines, uniform, space, uniformly, sorry, uniformly. So, okay, draw. Okay, you should draw uniformly. Okay, this one, uniformly spacing, like this. Okay, should be uniformly, right? Okay, then the D, this one is the D. Okay, separation between the lines. Okay, and then this one's the length of grating L. Okay, and okay, by using diffraction grating equation, by using the diffraction equation, diffraction grating equation. So what is the equation for diffraction grating? Okay, equation. So we use d sine theta. So I put n order equals with n order. Okay, this one is the equation. Equation for diffraction grating, right? And when the order is okay, first order, first order, okay, first order, and shortest wavelength 400 nanometer. Okay, you substitute in the equation. Substitute in the equation. Okay, just substitute in the equation. Okay, D. Okay, the D. Okay, but before we substitute in the equation, we have to use, because the D is not given, right? The small, this one, the D, distance between the lines is not given, so you have to determine first for the D. Okay, how to determine? You are given 10,000 lines per centimeter. Okay, determine the separation, line separation first. Okay, I have the n. I have n. The equation for lines per meter or lines per cm or the other one lines per mm. Okay, this one is the equation to determine. Okay, I have this equation. Okay, so I substitute. I do it in the next page. Okay, next page. So n equals to 1 over d. Okay, I substitute in here. So you rearrange because you want to determine the d 1 over n, right? Okay, and then at the end you should get this one is lines per am. Okay, lines per m is given. Lines per m is given. Let's see, lines per centimeter is given. Right, lines per centimeter. Per centimeter. Okay, so substitute in here 1 over. Okay, because it's 10,000 lines per centimeter, so I put as a 10,000 over 1 cm. Okay, this one 10,000 per. Here you have this. Because I rearrange, I want to determine the D. Okay, the D. Okay, 1 over. Right. Here will become my lines per cm. Lines per cm. Okay, so I rearrange the equation. I get back 1 cm over 10,000 lines. Right? This. Okay, equal. Okay, since this one is centi, so I have to make it negative 2 over 10,000 equal. Okay, so 1 exponent negative 2 over 1 exponent 4. So at the end, I get 1 exponent negative 6 meter. So this is a D. Separation between the line. Okay, there's more D. All right. Then we substitute in diffraction grating equation. Okay, D sine theta equals with n lambda. Okay, this one is my equation for diffraction grating. Okay, substitute. I have just now you get this one, so I substitute in here. 1 exponent negative 6 and sine theta equals with 1 first order when your n equals with first order. Okay, first order. Okay, 400. And because this one for shortest, okay, we go for shortest first. Okay, shortest is a 400 nanometer, right? 400 nanometer. Okay, then okay, maybe you can put it this one as a shortest. Shift shift sign 4 exponent negative 7 over 1 exponent negative 6. So I get at the end 23.58 degree. Okay, 23.58 degree. Right? Okay, what about for longest wavelength? 700. Right? Wait. Okay, let's spacing. Okay, for longest wavelength, to put it as a when order, first order. So first order, longest wavelength, 700 nanometer. Okay, we substitute same equation. We substitute in the same equation. D sine theta equals n lambda. Okay, this one you can put it label L, right? Okay, so 1 exponent negative 6 sine theta 1 700 exponent negative 7. Okay, then equals to shift sine 7 exponent negative 7 over 1 exponent negative 6. Right? Okay, then at the end I get 44.42 degree. Right? Okay. This one is for longest. And just now, this one is for shortest. Okay, you have the both angle. Right? I hope you all can solve the question. I hope you all can solve the question. Maybe okay. This. Okay. Okay, so the shortest theta is a 23.58, and the longest theta or longest wavelength theta 44.42 degree. Okay. All right. So we continue for our 1b. We continue for our 1b. What is the distance between What's the distance between the end of the rainbow of visible light produced on the screen for the first order diffraction? Okay, this one you have to use trigonometry, tangent. Okay, I draw for right angle. Draw for right angle triangle first. Okay, how do we see? You look at here, this question. You look at this question. Yeah, all right. So you have the shortest ys. Right, you have the shortest ys separation, and then longest. Okay, if you draw the right angle triangle, if you draw right angle triangle, so you see, okay, I draw for both, for the longest and the shortest first, right? I'll go for, okay, I go for shortest, lambda shortest first. Okay, theta shortest, this one, right? So I have the right angle 90 degree. Okay, this one is my, I put as a y, I put as ys, and then the distance is x equal 2 meter, right? So I use trigonometry, tangent, adjacent over, hypotenuse over adjacent. All right, tangent theta shortest over ys over x. Okay, x for this one, adjacent. Then ys cross multiplication, I get x tangent theta shortest s. Okay, so equal, I substitute all the information, 2, and then tangent 23.58 degree equals with 0.87 meter, right? This one is for y s, because the question asking about what is the distance between the end of the rainbow of visible light produced on the screen for the first order. Rainbow for this one for determine for shortest, and then we go for longest. Okay, I draw for longest. Draw it here. Okay, draw it here. Okay, I draw another right angle triangle. Theta, L, okay. Longest, theta. This one is my L, Y, L. Okay, I put a capital letter. It's X equals with 2 meter, right? Okay, tangent theta equal YL over X, right? Then I substitute my information. YL equals to cross multiplication. I get X tangent theta. Okay, this one we label. Don't forget YL. Theta L. Okay, equal to tangent. Okay, just now, how much we determine for our second theta? 44.42. 44.42. So we substitute 44.42. 44.42 degree equal. So how much do we get? 1.96 meter, right? So the first one for shortest, the second one for longest. Okay, since we determine the shortest and longest, so can we determine the distance between the end of the rainbow? Yes. Okay, therefore, distance between the end of the rainbow will be y longest minus with y shortest. Okay, so you can put it like this: yl minus ys equal with 1.96 minus 0.87. So we get 1.09 meter. Okay, 1.09 meter. So that means if we look at the figure 1, we look at the first figure of the question. Okay, that means if we draw the right angle triangle like this, right? Draw the right angle triangle. So this one is the longest, and then this one is the shortest. So you have the two right angle triangle. So we use the big y the longest minus the shortest. So actually you can get this one. Okay, you can get here spectrum. And you can see here. Okay, so I hope you all can understand. This is the calculation. Okay. Okay, thank you.